asking. Nice job. Those numbers are pretty sweet.
Are they? I hadn't even noticed. And how is Georgie doing?
He's doing great. I love working with that big guy.
Keep the doors coming, Charlie. I'm on a roll today.
George and I are like brothers. 2319! We have a 2319!
Red alert! Red alert! Red alert! Red alert! Red alert!
George Sanderson, please remain motionless. Prepare for decontamination.
Duck and cover, people!
Oh, not the CDA.
Coming through, please. Stand aside. Clear the contaminated area. This is a 2319 in progress. The area is clear. Coming through. Watch yourself. Stand back. Careful. All clear. Situation is 990. Ready for decon.
Hey, thanks, guys. That was a close one.
Okay.
Okay, people, take a break. We gotta shut down for a half hour and reset the system.
An entire scared floor out of commission. What else can we?
Assalamualaikum warahmatullahi wabarakatuh and good morning. I bid to all my fellow friends and our lecturer, Madam Narisa. So today our group represents about the methods of disinfection and sterilization. We are from group 5 and our group member are Faridah Aisyah binti Muhammad Shahril, Siti Nurfaqihah binti Rozlan, Amirah Syafiqah binti Jamaluddin, Sophia binti Shamsul, and Rabiatul Adawiyah binti Saifuddin. What is the meaning of disinfection and what is sterilization? So the first one is disinfection. Disinfection is a chemical process used to eliminate or inhibit the growth of bacteria and other pathogens that may cause infectious diseases in humans and animals, while sterilization is a process mainly used to kill all forms of microorganisms and its spores, and this process is carried out to maintain a sterile environment.
Next is the physical method of disinfection. The first one for the physical method of disinfection is pasteurization. The function of this method is to destroy all pathogenic microorganisms but does not destroy bacterial spores. This process is a heat treatment process that destroys pathogenic microorganisms in certain foods and beverage. It requires temperature of about 63 degrees Celsius, maintained for 30 minutes or alternatively heating to a higher temperature, 72 degrees Celsius, and holding for 15 seconds. The times and temperatures are those determined to be necessary to destroy Mycobacterium tuberculosis and other more heat-resistant, non-spore-forming, disease-causing microorganisms found in milk. Destroys most of the microorganisms that cause spoilage and so prolongs the storage time of food. Ultra-high temperature (UHT) pasteurization involves heating milk or cream to 138 until 150 degrees Celsius or 280 until 302 Fahrenheit for 1 or 2 seconds. Next, the milk needs to be heated to at least 138 degrees Celsius for at least 2 seconds. But because of less stringent packaging, they must be refrigerated. Pasteurization of some solid foods involves a milk heat treatment, the exact definition of which depends on the food. Radiation pasteurization refers to the application of small amounts of beta or gamma rays to foods to increase their storage time. Next, I will pass to the Sophia.
Okay, next, other physical method for disinfection is non-ionizing
ionizing radiation. Okay, firstly, I want to let you know what is ionizing radiation. Ionizing radiation is the use of short wavelength, high intensity radiation to destroy microorganisms and may resulting in a damaged cell, while non-ionizing use longer wavelength and lower energy and make them lose ability to penetrate substance and can only be used for sterilizing. Non-ionizing radiation is through the use of electromagnetic radiation. Okay, firstly, I want to tell you about the infrared radiation. These are electromagnetic rays with wavelength longer than those of visible light. These are low energy type. It also kills microorganisms by oxidation of molecules as a result of heat generated. Infrared radiation is used of rapid mass sterilization of pre-packed items such as strings and catheter. Okay, secondly, ultraviolet radiation, or we call it as UV radiation. The ultraviolet portion of the electromagnetic spectrum includes all radiation and will include UV light too. UV radiation is the more lethal to the microorganism. UV has a very little ability to penetrate matter. Thus, only the microorganism on the surface of an object exposed directly to the ultraviolet light are susceptible to destruction. UV radiation are used to sterilize operation theatre, laboratories, and entryways. And lastly is moist heat. Moist heat is one of the most effective methods where the steam under pressure acts as a bactericidal agent. Okay, how the microorganism kill is by coagulating their proteins.
Next is the temperature above 100 degrees Celsius. The moist heat sterilization above 100 degrees Celsius involves sterilization by steam under pressure. When pressure is increased in a closed vessel, the temperature increases proportionately. For about 15 pounds of pressure per square inch, the rise to 121 degrees Celsius. This pressure and temperature is kept constant for 20 minutes during autoclaving. It is sufficient to kill all the vegetative forms and spores of the organism.
For temperature at 100 degrees Celsius, they have two processes, which is boiling and sterilization. Okay, boiling is a process that does not ensure complete sterility, but it is enough for the removal of pathogenic vegetative microbes and spores. It also most effective when it is boiled for 20 minutes. It will kill most of the pathogenic organisms, particularly viruses and bacteria. Okay, for the sterilization, sterilization is a method that is used for sterilization of media with sugar and gelatin at 100 degrees Celsius for 30 minutes on 3 successive days. This is to preserve sugar which might be decomposed at a higher temperature.
Dry heat kills microbes by oxidation of essential cell constituents. It is less effective than moist heat. First, red heat. Sterilization is done by holding materials in a Bunsen burner flame until they become red hot. It is used to sterilize inoculation string wires, wire loops, tips of forceps, and spatulas. Second, flaming. This is a method of passing article over a flame but not heating it to redness. It is used to sterilize mouths of test tubes and flasks. Use scalpels, glass slides, and cover slips. Third, incineration. Incineration is the process of sterilization along with a significant reduction in the volume of the waste. It is usually conducted during the final disposal of the hospital or other residue. The scraps are heated till they become ash, which is then disposed of later. This process is conducted in a device called incinerators. Fourth, hot air oven. It sterilizes the objects that cannot be sterilized by moist heat. It uses the principle of conduction, in which the heat is first absorbed by the outer surface and is then passed into the inner layer. The commonly used temperatures and time that hot air ovens need to sterilize bacteria are 170 Celsius for 30 minutes, 160 Celsius for 60 minutes, and 150 for 150 minutes. These ovens have applications in the sterilization of glassware, battery plates, and even powder samples. Radiation. It is the process of exposing surface and objects to different kinds of radiation for sterilization. Mainly, electromagnetic radiation is used for sterilization. The major target for this radiation is considered to be microbial DNA, where damage occurs as a result of ionization and free radical production, which is gamma rays and electrons, or UV light. Non-ionization ultraviolet radiation includes light ray from 150 to 3900, of which 2600 has the highest bactericidal effect. Non-ionizing waves have a very little penetration power, so microorganisms only on the surface are killed. It is, however, applied in the sterilization of air, for the surface sterilization of aseptic works area, and the treatment of manufacturing-grade water. Ionizing radiation. X-ray and gamma rays are the commonly used ionizing radiation for sterilization. These are high-energy radiation which causes ionization of various substances along with water. These metabolites are highly oxidizing agents and kill microorganisms by oxidizing various cellular components. It is generally exposed to items in the dry state, which include surgical instruments, plastic string, and dry pharmaceutical products.
Now, without wasting time, I would like to present about other physical methods of sterilization, which is filtration. So, what is filtration? Filtration sterilization used for heat-sensitive materials to sterilize. This process does not destroy, but it removes all the microorganisms. And it also allows for the exclusion of organisms based upon size. Next, I would like to explain 3 examples of the materials that use filtration. So, the first one is depth filter. Do you know what is depth filter? Depth filters are the oldest type and consist of overlapping layers of fibrous sheets of paper, asbestos, and also glass fibers. Then, the retention of particles and microorganisms mainly in the dip of the filter matrix by mechanical retention and absorption. Other example for filtration is membrane filters. Membrane filters are made up of cellulose derivatives which are acetates or nitrate. They are very fine and are freezed in some suitable holders. They are suitable for sterilizing aqueous and oily solutions, but not for organic solvents such as alcohol and chloroform. In membrane filters, the membrane filters are generally blocked by dirt particles and organisms. This can cause pre-filtration reduces the risk of membrane filter. And the last example for filtration is air filter. One of the type of air filter is HEPA filter. HEPA is an acronym for High Efficiency Particulate Air. It is constructed of borosilicate microfibers in the form of plated sheet. Sheet is plated to increase the overall filtration surface area. The plates are separated by serrated aluminum wafers with direct airflow through the filter. And the last one is, this type of air filter can remove 99.97% of dust, pollen, mold, bacteria, and any airborne particles with a size of 0.3 micrometers.
So next, let me move to the chemical methods of sterilization.
is alcohols. Ethyl alcohol and isopropyl alcohol are frequently used as chemical agents for disinfection, and both of the chemicals facilitate the protein denaturation of bacterial proteins, and about 70% ethyl alcohol is the standard concentration which is used for disinfection. And this alcohol is used as the skin antiseptics, and methyl alcohol has activity against fungus spores and used to disinfection of inoculation cabinets. Aldehyde. It is one type of aldehydes, and it has its activity against bacteria. For example, the Mycobacterium tuberculosis, or we know it is the bacteria that cause TB, and fungi, virus such as HIV or hepatitis B, and it kills spores and less toxic nature, and it is used as 2% buffered solution. And the use of glutaraldehyde is for the sterilization of cystoscopes, endoscopes, bronchoscopes, and also for the sterilization of face masks, endotracheal tubes, and metal instruments. Halogens. So the next one is halogens. So the first example of halogens is chlorine, which is used in water supply, swimming pool, food and dairy industries. And chlorine compounds in the form of bleaching powder, sodium hypochlorite, and also chloramines. And the disinfection action of all the chlorine compounds is due to the release of free chlorine, which becomes a strong oxidative agent. The second example of halogen is iodine, which is in alcoholic and aqueous solution that is used as a skin disinfectant and active against tuberculosis and slightly active against spores. Compounds with iodine with surface active agents known as iodophos are claimed to be more active than aqueous or alcohol solution. Phenols. Lister, which is the father of antiseptic surgery, used phenol for the first time in the sterilization of surgical instruments. And phenols work as a disinfectant and kill microorganisms by cell membrane damage. And phenols is toxic for the skin. And the last one is the chloroxylenol. The example of chloroxylenol is Dettol, which is very common to us, and Dettol is commercially available as a chloroxylenol solution, and it is less toxic and less irritant, so it is safe to be used.